And we're back after the weekend. Welcome to 0x Hack. We are launching the first week of 0x Hack with a workshop from Status, which will be conducted by Franck Royer, team leader at Waku. He's going to do a 20-minute presentation and then 40 minutes of live coding. If you have any questions to Franck, feel free to ask them in the Hermit chat or on YouTube, and we'll make sure that they are answered. Also, make sure to hang out on our Discord. Franck is there to help you with your projects, to make sure that your bounties, that you will win the bounties from Status. We want to make your projects as good as possible. So yeah, I'm giving my voice to Franck Royer. Welcome, Franck.
Hi, thank you, and thank you very much. So hi, everyone. Yeah, so today we're going to talk about Waku and JS Waku. So as mentioned, I am leading the JS Waku effort. I'm part of Status, but I wanted to mention that Status has this new division, which that we call VAC, which is aimed to provide tools and libraries and infrastructure to the Ethereum ecosystem. So it's more about having some agnostic unbiased tools. Status use some of them, but VAC is really for the benefit of Ethereum ecosystem. And at the moment, the thing that we worked on most is Waku. So let's get right into it. All right, there you go. So trying to explain to you what Waku is. So I could do a lot of slides. So instead, I just go for a short sentence. So Waku v2 provides an infrastructure and standard for decentralized off-chain private communications to the Ethereum ecosystem, while considering the limitations of restricted resource devices. So quite a lot to unpack here. So let's just go slowly through different keywords we have in there. So the aim of Waku is to provide you infrastructure. So what we mean by that is that you don't need to run your own nodes. You don't need to deploy some AWS server to use Waku. Waku comes with its own infrastructure, like Ethereum, in the way that people are incentivized to run nodes, so that as the dApp developers that wants to use Waku, you don't have to run your own infrastructure. Instead, you can rely on Waku to provide that for you. Standard. So standard is more, so similarly to Web3, so it's more about having a common way of doing things. So whether you are building an app or wallet, you want to have one common way to do communications, and that's what Waku is aiming to provide to you. So standard as a best practice / common way of doing things, a bit like the Web3 interface where you have one common way to interact with the blockchain. So yeah, so it is decentralized, of course. So that's a characteristic of this solution. Decentralized, so that same than Ethereum, to avoid censorship, having avoid single point of failures, maybe legal risk and extra. So most likely, if you look at it's not us running one server somewhere and everyone uses it for communication. It is a decentralized system where anyone can run a Waku node and anyone can use the network for communication. Off-chain, so I just want to mention off-chain in the way that the solution is not about sending message on the blockchain and paying $20 or whatever the gas fee are for each message. No, it's having a separate network that will have some incentivization, but you don't have to pay gas fees for each message. There are some protocols, especially around spam, where there is interaction, or let's say there is ways to interact with the blockchain to lock some money so that you can kind of verify yourself and as a non-spammer situation. But it's mainly an off-chain system, which is a second network by itself. Private, so the private is more about enabling builders, so enabling developers. If your dApp needs end-to-end encryption or needs to keep some metadata private, then Waku enables it. So the way we build Waku and we specify Waku, keep in mind that, keep that in mind so that we can fit and fit purpose, any purpose that an app may have. So yeah, so that's part of private. And you can also decide not to do end-to-end encryption. You can also decide how much privacy you need, depending on your use case. Communication. So the aim of Waku is sending and receiving messages in various contexts. And that's basically the idea. So messages can contain text, images. So it's the payload is up to you, but that's the main goal of Waku: communication, sending and receiving messages. And Ethereum ecosystem. So it's built mainly for Ethereum. I mean, people could use it for something else, but we are building within the Ethereum ecosystem. And by ecosystem, I mean any kind of anything that is built on top of Ethereum. So we're trying to provide a solution that is generic enough that it can fit, whether you want to send messages between a dApp user to another dApp user, or you want to send a message from you as an operator or a dApp builder to your users, or you want to be able to users to communicate with you. It's really up to you to decide what you want. We want to provide something that is generic enough so that the whole ecosystem can use it. I said dApp, but it can be also wallet, or maybe layer 2, coordinations, anything that you can think of. Finally, restricted resource devices. So just a complicated way to say funds. So Waku v2 has been specified and built with funds in mind, in the way that we want it to be able to work on a phone where there is maybe limited data or limited availability, meaning the phone is not always online, and of course limited disk space and CPU. So we need this to work on such in such environment, so that your dApp can work on the phone as well as it work on a desktop browser. So a bit more on the origins. I think it helps understanding where Waku comes from. So I say Waku all the time. What I actually mean is Waku v2. So if you look at Web3, so maybe for the oldies among you know that Web3 comes from, yes, it's Web2, the next generation Web3, but it's also the trifecta of Whisper, Swarm, and Ethereum. So Whisper was meant for communication, Swarm for data storage, and Ethereum for the contracts. So the Status app, which is a decentralized messenger app plus wallet and a browser, originally one bit was using Whisper. But what they quickly realized is that Whisper is not really great for mobile phone environment. Main reason was for spamming protection, for example, it used proof of work. So it was hard to find a way to have a proof of work difficulty, which is okay for a phone to actually send messages, but also for desktop not to spam the network. And there was also no routing, which means that a lot of messages were sent and received from, by the phones, because there's no routing, so they receive all messages, meaning there was some bandwidth issues. So from there, Status created at first a Whisper Waku mode, which then became Waku v1, which solved a number of these issues. And reflecting back to the lesson learned, we designed and created Waku v2, which is a bit more, I would say, an improved approach of Waku v1. And this, so by a few ways. So for example, it is built on libp2p. Waku v2 is built on libp2p. And that's what we are currently we're going to talk about today. At the moment, the Status app use Waku v1, and there is ongoing effort to make it use Waku v2. Okay. I think so. From a personal experience and opinion, we can see, if you look at Ethereum and what has been built on Ethereum so far, you could see that when it was created, maybe it was a bit too early for Whisper and Swarm. For example, today, most NFTs are backed up on IPFS, which kind of becomes the de facto replacement of Swarm, at least from some point of view. And there was no, maybe not as much need before. And I feel like it's the same for Whisper and communication. Now that we have layer 2 and governance tokens, we can see more need for a decentralized communication solution, which was maybe not the case when Ethereum was created. So definitely a good time for Waku V2 to be live and be used. All right. So Waku implementation. So I just want to give you a bit of a view on the ecosystem. So what we have NIM Waku, so written in NIM, which is a high availability full node, which is a node that will be incentivized in the future for users to run this node. And it can also be used as a backend library. Status is running a few of these nodes so that even if it's not incentivized yet, you do have a network and you can already start to build things and start to test them out. We also have a Waku that is used to integrate in the Status app on the mobile, because Status app is mainly built in Go with other tech. And then we have JS Waku, which is what I work on the most, and that's what is you can use. So it's a client-focused library, and the aim is its aim is to allow you to integrate Waku in your dApp or wallet or anything you want to build. So in terms of features, what does Waku give you? So at the moment, so there is quite a few protocols. So all the code source code is open source and very permissive license, like MIT and Apache across the board. And the RFC's specification are also open source, and everyone is welcome to read them and propose new specification or propose modification on the specification if there is any improvement you want to see. At the moment, I want to talk about mainly 3 protocols that are the ones that will get you going. So we have Relay, which is, for those who know Lippy2P, Relay is based on PubSub and GossipSub. So that's for the near instant messaging. So being able to send a message and receive messages live. Because of the the restricted resource devices, so phones, we need to be sure that we cater for scenarios where a phone is offline, for example. So that's why we have the store protocol. So store protocol is mainly used once you resume connectivity. So once you have a network again, you can contact a full node, and the full node store all messages they see on the relay network. So you can contact them, and they will send you the messages that you missed. So you can contact them with a time frame, for example, which is a work in progress we have, or just contact them and they give you all the messages that they have seen, so that you can then show to your user any messages they may have missed from the relay network. And then finally, there is light push. So there's no green box there because it's work in progress on JS Waku. That's more for, I would say, scenarios where you don't have a very reliable connectivity. Then you can push a message directly to a full node so that the full node can then relay it to the network. Of course, there is some drawback on privacy there to take in account. We have other protocols which are specified. For example, at the moment, we're working on a spam protection protocol, which interacts with the contracts on the blockchain, and that's currently work in progress. At the end of the presentation, there is links to the RFC, so you can have a look yourself to see what we offer. All right. So now from a developer perspective, whether you're a dApp developer, wallet developer, while using Waku. So if you need some kind of communication in your dApp, whether it's user to user or operator to user kind of notification, or maybe user to service provider for maybe voting, things like that, today you can go the simple route, which is spin up an AWS server and have some central and add a central item in your architecture. Or instead, you can use Waku. So first thing that Waku does is that it removes the need of infrastructure for you. So you don't have to spin a server. Instead, you use Waku Network, and you can rely on people running Waku nodes. It's also an out-of-the-box solution, which is what we try, what I discussed in the second slide about standards. So something which is just work out of the box, just import npm library and get started. And the thing is that, so the back team, we have researchers and developers working on Waku, so that if you were if you want yourself to solve communication and do in a decentralized manner, this comes with a plethora of problems. So what we're trying to do with Waku is we're trying to solve these problems for you, so that you are able to have communication in your dApp without having to think too much about how is this solved. I would say it's exactly when you build a dApp on Ethereum, you don't have to think on how to fix Ethereum scalability. But of course, you are more than welcome to understand the problem and participate to the solution. But you can also purely focus on your dApp unique selling point and not have to think too much about the research problems that are behind communication or scalability for Ethereum. So that's kind of the idea of Waku. It just give you these tools and solutions so that you can focus on your dApp unique selling point. All right, so after our presentation, I'll do some live coding. But here is a small code example that you can have a look at. So written JavaScript. So JS Waku is written in TypeScript, which means that you can use it in JavaScript, of course, but if you use TypeScript or ClojurScript, you have the types as well, which makes things a bit easier. So library is called JS Waku, and first line is just start your Waku node with Waku create. Then you can connect to a peer. So here you can just decide to connect to one of your peer, or we also have some helper functions to connect to the status peers. So you don't have to have something hard-coded. You can use a helper to grab the status nodes. At the moment, we haven't looked too much into discovery. We are just waiting to solve other problems first. And once we have a more, a wider network, then we can look more into ways to do discovery in a less centralized manner. So if you want to look at messages sent on the network, so what you can see in the Waku relay, so using the relay protocol, and you have add observer. This gets you some messages, and you can just log the messages. And then you can notice in second argument, I have this my cool app string. So to ensure that your dApp only process messages they are interested into, we categorize all messages with content topic. So each message has a content topic. And then it really depends on your application. So you may look into using a content topic that already exists if you want to have some interoperability with other dApps or wallets. Or you may create your own content topic if you are doing a unique use case and you just want your dApp to have these messages, to process and see these messages. Now, to then send a message, so you can see on the next line, const message equal Waku message from UTF string, UTF-8 string. So again, to create a message, so you can pass a string and then your content topic. Here, I created from UTF-8 string as a simple example. But of course, you can pass a bytes array, so like having bytes as a payload, so that on your side, you can create your own data structure, which matches the purposes of your application and pass that in the Waku message. So it is generic enough. You can pass any kind of byte array, and then handle yourself how you want to decode and encode your data structure. And then finally, to send a message, and do await Waku relay send. And then you send a message to the network, to any peer that is connected to. So that's pretty much a very simple code example there. So now let's talk about the bounty. So bounty 3 for status is build an app with JS Waku. So in terms of ideas, whether it's private direct messaging, chat rooms, notification, layer 2 coordination, so I think there is a lot of use cases there. My creativity is quite limited, so I'm just looking forward to see what you are going to build with Waku. In terms of submission requirements, it just needs to be a fair usage of the dApp. So if you just use Waku to do some communication, but then most of your communications are done via some centralized servers, and we can't really count that in. But if most all your peer-to-peer provider-to-user communication are done by Waku, then the project will be eligible. Of course, communication does not need to be a central point of your dApp. So I think that's what's quite interesting, is that you could build a dApp for a specific purpose and have communication as a good way to have an extra feature that enhance the dApp, and then use Waku for that. I'm really looking forward to see what you build. All right, so ideas. So here's a couple of ideas I have. But again, I'm really looking forward to your ideas and your creativity. I feel like in Status, there is a number of ideas we have been looking into and thinking of, but I'm looking forward to some fresh ideas. So one idea, which is to have direct messaging between dApp users, and that could fit. Maybe your dApp is NFT focused, for example, and you could have a nice side feature for communication where you can like each other NFTs, or maybe have some private auctions, so sending some private messages to say, hey, I want to buy your NFT for that much. That's some possibilities. Or have something like a chat room where maybe people would discuss, or a troll box within your dApp, for example. And another more advanced idea is to use Waku as a way to anonymize some of Ethereum transactions. So not the transaction per se, but the broadcasting of them. So if you look at most wallets nowadays, so users typically don't run their own node, but instead rely on specific service providers. So which means that when you use your wallet and you connect to this service provider, they can dox you. So you send a transaction to them, so that when you get balance or send transactions, they can log your IP and say, okay, this guy most likely owns this address because he sent transaction that span from this address. So as a first step to try to help trying to fix that, you could use the Waku network to broadcast transaction. On one side, the wallet broadcast transaction to the Waku network. And on the other side, you use Waku, for example, and there is a JSON RPC interface on it to listen to Waku messages, which are transaction, and then send, and then this Waku Waku, or this bridge node can submit transaction to a full node. This, of course, doesn't solve all privacy issues. It's just like one step to helping with that. So something to think about. Yeah, so that's it for the presentation. Yeah, okay. So here are some links. I will send presentation slides in the Discord after the workshop. But links to Bounty, links to the repo. There is one showcase, which is a chat app, so you can play around with, which is built in React.js using Waku. And we have a spec, we have a forum, we have the Discord as well. Once the hackathon finish, feel free to join our Discord on the Status repo. All right. So if you have any question, now is a good time, because I'm going to change screens to share my screens for coding purposes. So just give me a couple of minutes. All right, back on. So if I can have a quick message, someone confirming that they can see my screen, it'd be great. I know the code is a bit small at the moment, so I'm just going to increase that. Okay. Okay. All right, so for now, just have a look on the right-hand side. So yeah, okay, cool. All right, awesome. So just for now, just focus on the terminal. So let's get started. So I'm just going to just create a, so as I mentioned, we have a chat app that is, so a React.js chat app that is available. And actually, Waku and Waku also have a little chat app to interact. And that's how we do some dog fooding, just to use network, as people are building dApps, we just want to use network. So we have this little chat feature. So we're just going now, what we're going to do is that we're going to use JS Waku to create a React.js chat app from scratch, okay? So just on the right-hand side of the screen, so let's start with npx create React app, and let's call it chat Waku. All right, so let's jump in the repo. I'm just going to do some cleanup here. Just just install those packages. Okay, just waiting a bit. Live coding, hopefully everything will go well. All right, let me just check something because we had some issue with Babel recently. So let me just check that we're good on the versions. Yes, we're good. And then npm install JS Waku. And I can start to open this new project in my IDE. So chat Waku, there we go. Okay. Okay, all right, so let's just increase the font here. Yeah. All right, so I'm just going to do npm run start, and that gives me a nice browser window to show my React app. I'm just going to move that away. Okay, here we are. So yeah, so I have my React app here ready, and yeah, let's start coding. So app.js Okay, just checking, is font okay? Let me just quickly check in the chat, confirm the font is okay. I got here the chat. Okay. All right, just jump in the live chat if there is any issues. I'll keep a look there. Okay. Cool. All right. So, all right. First thing we want to do is create a Waku node. So it's an async process to create Waku node. So we're going to use the use effect function in React. So I'm going to have my Waku node as a property of my app. So just using use state from React. Now, so if I don't have my Waku node, so if not Waku, then let's create a Waku node. So just going to call it Waku node for now. And what we said Waku. So automatically imported from JS Waku dot create. All right. For now, I don't want to pass any options. Let's use a way to sync for now. I mean, you can use, or let's actually just do combination. Let's do then just make it easier in React, I think. Fine. All right, so Waku create, and then we end up with a Waku node. Let's just maybe log something. Let's have Waku node created, and maybe we can have the PID. So for those who are not familiar with lip2p, the PID is this unique identifier for your node. Okay. Here. All right, and so we're going to log that we have the node created, and then we are going to save it in the state of our app. There you go. All right, compiling. Open the console here. All right, can I make the console bigger? There you go. Cool. All right, so lots is going on already, and you can see here, Waku node created. All right, so we have a Waku node. Awesome. Next thing we want to do is connect to other nodes. So as I mentioned, we do have a little helper at the moment, which is called get status fit nodes. Because at the moment we are basically the only one running nodes, this is quite helpful. But once we have a more heterogeneous network, more people running the nodes, then we can move into having some discovery. So get status fit nodes does a query to status server to know what nodes are going on, are available, are running. So we have a string of addresses, basically. And from there, we're just going to connect to them, okay? So node dot for each. So they're just addresses. We can directly pass them to our Waku node. So we're going to do Waku node dot dial and pass the address. So actually, I should I'm going to set the Waku just at the end here. Yeah, so just keep the change the property at the end. So as soon as we start the Waku node, we're grabbing the status nodes, and then this return an array of strings that are different multi-addresses. And we're just going to, for each of them, we're going to dial all of them. So then we can just log something, console.log. Just going to Waku connected to address. There you go. All right. Yeah, let's have a look. Let me just check this chat to see everyone is fine. Oh yeah, sorry, strategy just here. All right, okay. Okay, my connection seems to be a bit poor. Let me just all right. Yeah, looks like. Oh no, the screen share, I think it's gone. No.
No już jest.
All right, this was
Wyłącz.
everyone. I'm back. Okay. Can you hear me? Can you see my screen? All right. Can you hear me now? Yes. Okay. Can you see my screen? Okay, cool.
Jesteś ciągle podłączony.
All right. Okay, so we are back on. Okay, so yes, we have our changes here. We're just looking, for now, we're just working with the console. Here, so just filter on Waku. Caps lock. Yeah, so we had node created, and then we wanted to connect to each node. So yeah, just yeah, let's just refresh on that. All right, so okay, then back to the dial. So we grab the addresses, and then we dial our address, and just have a little console log to see if I'm missing something obvious here. Well, that should be fine. But obviously it is not. Okay. Let me just quickly grab my cheat sheet. Huh. Okay, just checking that. So let's maybe add some errors. I wonder if the nodes are down. Now we have our nodes here available. I did thought that live coding would be challenging, but so I'm just checking. Yeah, should be fine. Should be fine. Okay. So what I'm going to do, yeah, just catch here. So catch error. So So here, and then here as well. Oh, okay. So we're fine now. We had a fluke. So okay. So back to where we are. So we are connected. We are dialing nodes, and now we are connected. I wonder if someone just redeployed the node during the demo. I don't know. I have to have a look after. Okay. So what next? We want to send. Yeah, let's see, receive some messages. So to do that, we're just going to jump. So before we connect, we are going to do exactly what we had in the slide, which is just add an observer, all right, to just look for new messages. So I'm going to store these new messages in the state of my app. So just again set new messages using new state. Or for now, just going to have one message at a time. All right, so set new message. Sorry, just adding here, forgot to do that. So just the way that use effect work, just need to tell use effect what dependency needs to watch. So that if that change, then it can run the function. So yeah, so let's add an observer. So we have our Waku node, and we are going to look at new messages on the relay network. We're going to add an observer. So the observer needs 2 arguments. So we're going to have a callback which process Waku messages. So I'm just going to grab my Waku message. And here I'm going to process it. So in this case, for now, I'm just going to set new message. I'm going to directly, add the Waku message to my state. I'm just going to log message received. Okay. That's fine. Now, yeah, so now let's do something with this message. Okay, so my message received, yes, so second argument is a content topic. So as I mentioned, each message has a content topic. So we categorize with that. So for this dog fooding app, so this app that we use to, this chat apps that we use to play with things and ensure that this work is working and trying to new feature, or content topic is Dingpu, because our VAC lead is in Taiwan. So yeah, so I'm only interested in these messages. So I'm going to just pass one content topic here so that I only process messages which have this content topic. Now let's just do some React code. Again, so just kind of disclaimer, I am not a React developer, so I'm doing my best here. All right, so new message. And so this message is a Waku message. So at this stage, I'm just going to grab the payload as UTF-8. So just like a little helper function here. Little helper getter. Yeah, so if it's only 55. That just say, oh, you have a Waku message, just consider that as UTF-8. But again, we come back to that. Most likely, you want to have a data structure here. All right, so let's have a look now. Cool. It seems not like some of the nodes here. It's connected to. So I did try this a few times. There's one node it doesn't like. Okay, so it looks like only there is one node that is down. So for now, yeah, it looks like there's one node that has some difficulties today. So, oh yeah, so at the end, wait. What do I do? Ah, I put that in the wrong place. There you go. Okay, yeah, so let's remove the logo as well. We don't need the logo here. All right, so cool. So let's send a message. So as mentioned, we do have chat app running somewhere. So it's on the GitHub page. So I'm just going to open the chat app that I have running on GitHub page. Just going to wait for it to load a bit and chat app in the bottom. Yeah, it's fine. All right. Hello world. Yay. Hello world. So we're good. So one thing that you may notice here is that we have a strange character. And here that's the nickname here. So you can see my nick. So just going to SFJS pages. All right, so that's my nick, and here's a strange character. So I kind of cheated here because actually the payload of the Waku message is not a UTF-8 string, but it's a protobuf payload. But because there's no extra, it works because it keeps the string as UTF-8. So as I mentioned, you can use byte arrays and you can put whatever payload you want. So in the case of chat app, we have a chat message payload. And because something we use quite often for the concept, it is added to the library. But I expect you to come with your own payload depending on your own use case. And let's look if there is any questions so far. Okay, yeah, 5 minutes. All right, going to jump. Okay, well, let's send a message. So try to jump to the payload. Okay, send message. So what I'm going to do here is that instead of having a Waku message, I'm going to have a chat message and chat message just decoding. So Waku message dot payload. So the payload as a byte array. Okay, here. And now we have chat message. And so this new message now is a chat message. So I can just going to have a very simple string where I'm going to say chat message dot nick chat message. Oh, it's new message, right? New message. So this time the payload as UTF-8 is actually a correct usage here. Chat message not defined. Yeah. Yeah. Yes. There you go. Here. All right. Okay, so hello again. I went too fast. Hello again. There you go. So this time it's decoding things. And yeah, so let's have quickly how to send a message. It's going to be short in time. Going to wrap up. Yeah. I can I think, yeah, so that's a basic idea. So I have another demo. So I have a repository where I did the demo fully. So you are more than welcome to have a look there. Oh, you have a... Oh. All right, so let's go to questions. With using decentralized communication means that the DApp will be 100% of the time? Yeah, so exactly. So Osama, a question from Osama, whether by using decentralized communication means that the DApp will be 100% up of the time, opposed to having a central server. So yes, absolutely. But again, you need to look at your own DApp architecture and understand what are the elements. So using Waku, you can offload communication to Waku. But then you also have question, where do you store your DApp? Like for example, from where do you serve the JavaScript code for your DApp? And that could be centralized as well, or you have to have a look somewhere else. So that's one thing that you may want to look into. But with Waku, it definitely helps you decentralize some part of your DApp. Okay, so if you have any other question, please let's go for it. And I will share the slide in the 0xHack Discord so that you can have a look a bit more at the example. I am Franck Royer on Discord, so I'm available on the status chat of Discord, so feel free to ask any question you may have.
Hey, Frank, thank you very much for your workshop. To everyone attending, feel free to join Discord. You can get any answers to any questions you might have. And up next is Alberto Viera. He will tell you more about bounties from Moonbeam and give you some technical background that you need to compete for the bounties. Alberto should be here in a minute. Let's give the stage to him.